Hi, I'm Fiona from Keboola. Today, I'll walk you through a use case that you can build on the Keboola platform. First, I'll explain the business objective and outline the technical solution. Then, we'll build the pipeline from scratch in Keboola. Feel free to follow along. So what's the use case? Imagine you run an online store and want to automate personalized marketing campaigns for your customers. In this example, the store operates on Shopify. We'll use customer and product data, process it with a generative AI tool to create personalized messages about relevant products, and automate the entire pipeline. However, to ensure accuracy, we'll include a step where someone can review and approve the messages before they're sent. Sounds simple, right? This is just a model example. You can adjust each step or component to fit your needs. For instance, you could create campaigns for products that need to be sold quickly, or send emails instead of text messages. The possibilities are endless. Here's the final pipeline set up in Keboola's Flow Builder. Let's break down each step. Data extraction. First, we'll extract data from Shopify into Keboola storage. You can also source data from multiple platforms like Salesforce or an internal MySQL database. Data preparation. Next, we'll combine data from various tables, filtering out irrelevant information for this specific use case. Generative AI. Once the data is ready, we'll use a generative AI app in Keboola to generate personalized messages using Google Gemini. Data approval. After generating the messages, we'll run a simple SQL query to prepare the data for approval. Data app for approval. To streamline the approval process, we'll create a lightweight data app. Message sending. Finally, once the messages are approved, they'll be sent using an API call to Twilio, a service for sending automated text messages. Before we start building this pipeline, there are a few things we'll need to have set up in advance. A Keboola project. You'll need an active project in Keboola to build and run the entire pipeline. A Shopify account. Make sure you have access to your online store's data on Shopify, as this will be the primary source of customer and product data. And Gemini API token. This is required to authorize the generative AI component that we'll use to generate personalized messages. A Twilio API token. You'll need an active Twilio account with an API token to send the text messages generated by our pipeline. Make sure these are ready before proceeding, as they are essential for the pipeline to function correctly. Let's start by creating a project. If you already have one, you can skip this step. Creating a project on Keboola is simple. Just go to Keboola.com, click the Try Keboola for Free button, and authenticate. A new project will be created for you. Next, we'll create our first flow. Navigate to Flows in the menu. If you've already created some flows, you'll see a list with a green Create Flow button. If not, the button will appear in place of an empty list. Let's give our flow a meaningful name and a brief description. This helps keep everything organized, especially when collaborating with other colleagues on the project. Now we're in the Flow Builder, an interactive canvas that helps us design the pipeline visually. Let's start by extracting data from Shopify. Click Select First Step. Each step in the flow can perform different actions. Extract data from a source, like Shopify. Write data to a destination, such as a database or an API. Utilize third-party applications, like a generative AI tool, to enhance or process data. Create transformations to clean, merge, or prepare data from multiple tables. In this case, we'll start by setting up the Shopify extractor to pull data into Keboola storage. Let's find the Shopify extractor and click Create New Configuration. In this example, we'll work with demo data, but typically you'd choose Connect to My Data and configure the necessary parameters, such as your Shopify API token and data loading settings. When creating a component configuration, it's important to give it a clear name. This is because each configuration can be reused across multiple flows, and a consistent naming convention helps keep everything organized. We can run the component right away to load the data into Keboola storage for further processing. Simply click the Run Component button, and the job will run in the background. It will be linked to a job in the system. In the Last Use section, you can see who initiated the job and check its status. Once the job completes, a green icon will appear showing the execution time. If the job fails, the icon will turn red. Now that we have the data in storage, we can review any of the tables by opening its detailed view, which shows the size, number of rows, and a data sample. Now that we have the data in storage, we can review any of the tables by opening its detailed view, which shows the size, number of rows, and a data sample. Another useful feature is the ability to check the usage of a particular table across the entire Keboola project. We're now ready to return to the flow and create a transformation to prepare the data for the AI app. Let's add another step to ensure the data preparation starts only after all the Shopify data has been loaded. Since we'll be working with SQL, we'll select the Google BigQuery transformation. Click the Create Configuration link and give your transformation a meaningful name and description. Remember, descriptions support Markdown, which is helpful for documenting your project, whether it's for storage, components, or transformations. Next, we'll configure the transformation by setting up input mapping. This allows us to define which tables we'll be working with. Click New Table Input and select the tables from storage. You can also select multiple tables if needed. In this case, we'll choose the line item, order, product, and customer tables. Once we've set our inputs, we can write the SQL query. Click Add New Code, give it a name, and then start writing your SQL statement. After entering the code, make sure to click Save. A few things to keep in mind. There's no limit to the length of your code block, so you can write as many SQL statements as needed. However, it's clearer to organize different parts of your code into separate blocks for easier management. Code blocks are executed in the order they're listed, so be mindful of the sequence. Next, we'll configure output mapping to specify which tables should be sent back to storage. To do this, click the Output button, then select the tables you want to export. You'll need to provide the table name as used in your SQL, create table statements, and choose a storage bucket, or create a new one. You can also rename the table before sending it to storage. Again, as in the next step, we will be working with the data output of this transformation. We will first run it and make sure we obtain the result we need. While Keboola excels at orchestrating data workflows, you may prefer using the advanced tools and features of your favorite IDE for exploratory analysis or fine-tuning SQL queries, such as dbeaver, datagrip, or others. If so, you can connect directly to your BigQuery workspace, where all the files are loaded, allowing you to work in the environment you're most comfortable with. For more details on how to set this up, check our documentation at help.keboola.com. Let's return to the Flow Builder. In Step 3, we'll set up the Generative AI application. First, locate the component, create a new configuration, and click the Connect to My Data button. As always, give the configuration a clear name. Since we're using an external service, an API token is required. You can select the AI service provider of your choice, and you'll need to provide the corresponding API key. For most Keboola components, a documentation link is available, so you'll always have guidance on how to set things up. To set up this configuration, we need to add individual rows for each data operation. Let's create a row and name it Twilio_SMS_campaign. Next, we'll configure input mapping, where we specify which table from Keboola storage the application will work with. We'll select the SMS campaign 01 table, which was created in the previous transformation. Since we've selected OpenAI, we can list the available models and choose the one that best fits our needs. The configuration options below may update accordingly. You can always fine-tune these settings to achieve the best results, but for now, we'll keep the default configuration. Additionally, some templates are available to help with common use cases. Now we can design the prompt. Go ahead and fill in the prompt. Before running the entire pipeline, it's a good idea to test the prompt first to ensure you're satisfied with the results you're getting. Last but not least, we'll set up the destination in Keboola storage, where the prompt results will be saved. Let's give the destination table a name. If appropriate, we can choose to write the data incrementally, For the primary keys, we'll use the customer_ID and phone columns. Once we've completed the configuration parameters, we'll save the settings and run the component. Once we've completed the configuration parameters, we'll save the settings and run the component. This will allow us to test whether everything is working correctly. After execution, we'll find the output file created and available in Keboola storage. Let's take a moment to review. Since storage is a central part of the infrastructure, let's take a brief look at it. This is where all tables and files are stored within the Keboola platform. The tables are organized into buckets, which function similarly to folders on your computer. In the storage section, you can navigate between tables and buckets, files, storage jobs, and events. The tables and buckets section is essentially your table storage area, containing all buckets and their corresponding tables. Each bucket can hold one or more tables. By clicking on a specific table, you'll be taken to its detailed view. The Overview tab will display the table's ID, name, and primary key, if set. You'll also see the most recent configuration that updated the table. Additionally, you can view details such as when the table was created, the date of the last import or change, as well as the row count and size of the table in storage. Let's take a moment to review our progress in designing the full flow. So far, we've extracted data from multiple Shopify tables. In Step 2, we processed that data and created a single table to pass through the Generative AI app for our marketing campaign. This table contains both customer and product data for the campaign. In Step 3, the Generative AI customizes a message for each customer and saves it back into storage, ready for further use. 3 steps down, 3 more to go. Next, we'll prepare the data for internal approval, design the data app for the approval process, and set up the component to send the actual text messages. Now let's return to the flow setup and finish it. We'll create another SQL transformation this time to prepare the data for the data app that the marketing manager will use. We'll follow the same steps as before. Click the Add Task button, find the BigQuery transformation, create a configuration, and give it a name. Next, we'll set up the input mapping by selecting the table we created in the previous step of the flow. Twilio_SMS_campaign_source_data. To make it easier when writing the query, we can rename the table within this transformation. Let's call it Twilio_source_data. Now we'll write the SQL query in the code section and save it. You'll notice we're creating 2 tables in this transformation, which will need to be reflected in the storage. The first table is a test table, where we filter for a specific ID. This is useful if you want to test a new message format quickly. The table will be ready for that purpose. The second table will be used in production, and we'll use it in the data app in the next step. In the output mapping, we'll be creating 2 tables based on the SQL query. Let's rename the bucket for these tables to Campaign Executor. Once that's set, we can run the component to ensure everything works successfully. Now we're at Step 5. Setting up the data app. Go back to the Flow Builder, click the plus symbol to add another step, and choose Data App. This will allow us to create a user interface where the marketing department can handle the approval process, avoiding the need for a complicated CRM integration. This approach is quick and efficient. After naming the data app, we can proceed to configure the component fully. Data apps are interactive applications or dashboards built using Streamlit, a Python library designed to simplify the creation of web apps that display and interact with data. Streamlit allows you to turn Python scripts into user-friendly, shareable apps with minimal code. At this point, you can choose your preferred authentication method. For this example, we'll use basic authentication with a username and password. Data apps also support security via OIDC authentication, allowing integration with your identity provider, for example, Entra, Okta, Gmail, or others. Note that if no security settings are applied during setup, the data app will be publicly accessible via its URL. Next, decide whether to pull existing code for the data app from GitHub or write the code directly in Keboola. If the GitHub repository is private, authentication will be required. In this case, we'll use code from a Git repository. The URL where the app will run can be partially customized in the additional settings of the app. You can adjust the URL prefix to make it easier to quickly identify which data app is behind a specific URL. Since we're working with Keboola storage and using the variable kbc_storage_token, we'll need to specify it in the secrets section. Name the variable and insert the value you generated from the project settings section. Let me take this opportunity to show you how to generate an API token. Open Keboola in a new tab and navigate to Project Settings. There, you'll find a tab called API Tokens, where we can create a new token. We have various options to customize the token to ensure a secure environment. For instance, you can create a token that's authorized only for a specific component. In this case, we'll allow full access. Once the token is generated, copy it and paste it into the secret value in the data app. When reading from tables stored in Keboola, you can load the data either via an API call, which requires the API token, or by using input mapping, just like in a regular transformation. Now it's time to deploy the data app. Click Deploy Data App in the upper right corner and wait for the job to complete. Once deployed, you can run the data app by clicking the Open Data App button. Before the app opens, you'll see the URL where it can be accessed, and since we selected basic authentication, the password will also be displayed. You can easily copy the password by clicking on it. Now, let's open the app. The app will load, and users can immediately start entering data. It validates and securely saves the data within Keboola. And that's it. We've just created and deployed a data app within Keboola using Streamlit. This integration makes it easy to automate your data workflows and ensure data quality. Now, we've reached the final step of our flow, making sure the customized messages are sent. For this, we'll use our demo account with Twilio. Let's add the Twilio component to the flow and give it a name so we can configure the parameters. First, we'll authenticate the component. Twilio uses an API token for authentication. We'll also need the account SID and messaging service SID, which can be found in your Twilio account after signing into the console. Next, we'll set up the input mapping by selecting one of the tables we updated with the data app. The data app adds true or false values for each customer and message. To ensure we only send approved messages, we'll use a filter in input mapping to select rows where the approved column is set to true. Once the input mapping is saved, we're ready to run the component. We've successfully created the entire flow, incorporating generative AI and a data app as a user interface for our marketing department. The final step is to set a schedule to automate the whole process, ensuring our pipeline stays up to date. In the Flow Builder, click the Set Schedule link. You'll see we have a variety of options for scheduling when to run the flow. By default, the time zone is set to UTC. Let's schedule the flow to run once a day and save the settings. And that's it. If you have any questions, feel free to reach out to us.